Hi everybody, welcome to my Python tutorial which is called So You Want to Learn to Code. My name is Bryson. I'm a support specialist at the University of Lethbridge Library. That essentially means that I'm an IT guy and I use Python quite a bit at my job here in the library. I'm really excited about it. I think it's a great language to learn, especially if you haven't learned any other programming languages before. It's a great one to start with. So I'm excited to share with you today why Python is great, give you kind of a bit of a crash course on how to use it, and hopefully I can just get you started on your Python journey. So to get started with, I'll just mention that Python is a programming language. It is something that you can download. It's free and open source, so that means you can download it without any cost. You can install it. You can see all the code that's running behind the scenes. There's nothing that's sort of hidden. And as I mentioned, it's a great language to start out with, fairly user-friendly and fairly intuitive. Yeah, so before you kind of go and download Python and install it on your computer, if you have already, that's fine. I feel like it's a bit confusing to have people go and do that step and run Python code directly on their computer. It is an option, and it's something that you might want to do down the road, but if you're just starting out, I do recommend that you use something instead called Google Colab. So what that is it's a service that Google offers that lets you run Python in your browser. So it's running something called IPython, which is short for interactive Python. And it's just a way, as I mentioned, of running code in your browser, so you don't have to install anything. And it's kind of a good way to start out with because, as I mentioned, I'm not kind of expecting any sort of programming experience at all. So this is maybe kind of a good way just to jump in a little bit and give it a try. And if you feel like downloading Python later and running it on your computer, that's fine too. So to start with, I'm going to have you go to this URL here, and I will put a link to that in the description, but this one here. If you go there, it will take you to, I'll read it out for you. It's www.uleth.ca/lib/python. That's just sort of a shortcut that's going to take you over to this here, which is the Google Colab notebook that I've created to teach things. So this is essentially like an interactive textbook. So you can have images in it like this, you can have blocks of text, and you can also have code blocks. When you first go to it, yours might not look quite the same as mine. For starters, you might have like a little icon here that says save to Google Drive. So the way this works is, as I mentioned, you're running Python in your browser. So what Google does is it'll be starting up a computer for you that's going to run the Python code. So what you're doing is sort of writing code. You send it to this like computer that's running in the background, and then it runs the code and then kind of sends you back the results. And so you kind of need to have a Google account for that to work. So like a Gmail account or something like that. If you haven't already, it'll ask you to sign in. I'm signed in, so I can see my picture there. But when you start running code, it'll make sure that you're signed in before you can do that. So to get started, your Google Colab notebook might look a little bit different than mine. So I have some settings changed and stuff, like I have the dark theme on. So if you want to change these settings, you can click on this gear icon here, and that's where you can go to do that. But it doesn't matter if how it looks. Like, you should be sort of ready to go just from the start here. Some things I'll mention is that this notebook is always available, so you can always come back to it and work on it. It's not like it'll go away after a certain amount of time. I plan to have this up and always available. It's sort of made up what are called cells. So you can have text cells and code cells, and you can kind of see if you hover in between the cells, it will give you the option to create a new one, a new text cell or a new code cell. These are just text cells here because I'm just sort of giving a brief introduction on things, and then as you get further down, we'll see our first examples of some code cells. You'll notice that in the top right, there's this connect. It should say connect if you're just starting it for the first time. And so this is gonna, as you can see here, if you hover over it, says connect to a new runtime. So this is where you're gonna start up a computer in the background that's going to actually run the Python code. So I'm gonna go ahead and click that, and you can do that too if you'd like. If you haven't already signed into this notebook, then it'll ask you to do that. Feel free to do that. And we can see now here, this is the computer that's kind of running behind the scenes that is going to run our code for us, our Python code, so they don't have to install anything ourselves. So I will just quickly mention here, if you do have an icon over here or a little thing that says save to drive, I do recommend clicking that as well. that's going to create a copy of this notebook in your own Google Drive account so that you can edit things, you can customize things, because otherwise, like, you should still be able to run the code examples if you don't do that, but any changes that you make to things are going to go away once you sort of finish up here. So I recommend clicking that so you have your own copy to work with. You can take your own notes if you want to. You can edit my code examples. You can add your own examples and change things. So feel free to do that if you haven't already. So I mentioned that this is a text cell here. If you double click on it, you should be able to edit the text. We don't need to do that right now, but it's an option if you want to do that. If you want to take your own notes in here, you can do that, or add your own code or text cells. But yeah, we'll kind of jump into things here and get started. So I like to kind of start out just by doing some basic math with Python. I think that's just a good, simple way to jump into things. So you can see here how you can do that with Python. So it's kind of the basic symbols that you'd expect: addition, subtraction, multiplication, and division. Just point out that multiplication is using the asterisk here, and division is using the /. The other three examples here are things that you probably won't end up using very often, but I include them just in case. So all these examples will add up to 9, in case that helps you understand what's going on here. So like 3 to the power of 2, for example, will give you 9. I wouldn't worry too much about those last 3, but just the first 4 are the ones that you use more often. So we're going to get to our first code cell here, and we can see that we're just doing a very simple math equation, 4 plus 3. So our code cell has this dark background, and you can click on the plus sign to run the code. So go ahead and do that. Now, if this is the first code cell that you're running, you might get a warning message saying, like, this notebook is not authored by Google. Do you want to run the code? You can go ahead and click yes on that. It's just saying that it's not an official Google Colab notebook because it's written by me, but you can feel free to run that because I promise there's nothing crazy going on there. But if you run that, you should be, again, we're sort of sending this equation, which is like some very simple Python code that's just solving a math equation, sending it to this computer over here that's running, and then it should give you back your result, and it should give you back 7. So just give that a try, and feel free to follow along with the examples as we go. And like, if you ever have a question that you're like, oh, what happens if I do this? Just give it a try. Pause the video for a second and try it and run things and see what happens. I think that's probably one of the best ways of learning Python, is just by figuring out your own questions that you want to ask, and the only things that you want to do, and try that and see what happens. So that's a very simple example. The second example here is also fairly simple, but here it's just showing that Python follows the order of operations. So it's going to do this operation here first because it's in brackets. So it'll do the brackets first, 1 plus 2, and then it's going to multiply that by 4 after, because normally multiplication happens before addition, but because it's in brackets, that's going to happen first. So 1 plus 2 is 3, and then we're going to multiply that by 4 in the end, which should give us 12. We'll run that just to make sure that's what we get, and we do, which is great. So scrolling down a little bit further here, we're going to, so this little icon here, it's an Uno reverse card. I don't know how many people play Uno or how common it is, but it's just my way of saying, like, you'll see this kind of throughout the notebook. It's my way of saying, hey, this is your turn. Now I've written this code. Now it's your turn to write some code. So I give you just kind of a blank box down here to do that with. So the example here is to write an equation that adds up to 5. So whenever we run into these things here, feel free to pause the video and give it a try yourself, and then I'll do it along as well. So the way I would solve this is you can do a more complicated equation if you want to, but it could be something very simple. So I'm just going to do like 2 plus 3 in this case and click on play to make sure that works. And we get 5, which is what we expect. Yeah, just a way to make sure that you can write your own code. So give that a try, make sure that it works for you. Scrolling down further, we're going to talk about data types, which are the ways that that Python stores data internally. I'll start with just a few examples. Here are kind of the common ones. So we have integers, which are numbers that don't have like a decimal place. It can be negative or positive. So examples are -1, 0, 1, 2. And we have floating point numbers, which are ones that do have a decimal place. So we have like -0.5, 0.0. Anything with like a decimal place is any numbers like that, they're going to be a floating point number, negative or positive. We have Booleans, so these are the only 2 Boolean values, true and false, and they have to have a capital T for true and a capital F for false. We're going to talk about that in a little while when we get into control flow, because you'll want to do things based on a statement, like if the user's password matches, then you want to let them into the system, for example. So you have to say, like, is the password, does it match? Is it true? Then you'll do something based on that. So we'll get into that in a little bit. And then the fourth example here are strings. So strings are just like a series of characters. So the way that you sort of tell Python something's a string is you use quotation marks. So the first example here uses double quotation marks. And we start with the double quotation mark, then we have our string. So hello world is our first example, and then it ends the string with the double quotation marks as well. So that includes all the characters here, the space, and the exclamation mark. That's all part of the string. Second example here, so I just use a comma to show there's a second example. It starts with a single quotation mark and ends with a single quotation mark. That works just as fine as well. As long as you're kind of consistent. You have to make sure you start and end with the same thing. So the second example here is the third example is another one that uses double quotation marks, but you can see we have a single quotation mark in the middle of it. That's just because we want to use it like an apostrophe. So that's perfectly fine. It's not like it tries to create a new string here or anything, because we are already part of a string with the double quotation marks at the beginning and end. It just treats this like a hyphen, so it's not trying to turn this into a string or anything. If you happen to start with a single quotation mark and then you try to use this like a hyphen, you're going to run into a problem, because it's going to say, okay, now the string's done, right? Because the start of the string is here, and the end of the string is here because we ran into this thing, and then it's going to get confused because it doesn't know what to do with the rest of this. So if you happen to be wanting to use a single quote inside of your string, then just start and end with a double quotation mark. And then the last example here is to show that you can have numbers as part of a string. So whereas before, like this, we had integers, right? We were working with integers and doing math. Python isn't treating this like numbers. You can't do math with this. This is just treating it like the character 1 and the character 2. So kind of important, because we're going to look into some examples in a little bit that show that it matters how Python is storing something internally. So there's a string that has numbers in it as an example. So scrolling down a little bit further, we've already worked with integers a little bit, so let's try just seeing if we can get a floating point number. So here's an example of division that doesn't divide evenly. If we run that, we should see that we get a floating point number. We can tell because it has decimal points after it. If we go down a bit further again, we can see that we have, this should give us a Boolean value as a result, because we're using this greater than symbol. We're asking, is 16 greater than 3? It is, so we expect it to give us back true, and it does. Again, we've got that capital T to show that it's a Boolean value. And then we've got a couple of examples of strings. So the first one here is just to show again that we can start and end with a single quotation mark. It's very happy to do that. If we run this example, it just gives us back our string, right? We can tell that it's a single string because it starts with a quotation mark here and ends with a quotation mark here. And then, so we looked at some operations before, like math operations, like addition and subtraction. You can also do some operations with strings. And the most common one is called concatenation. And that just means putting two strings together into a single string, combining them into a single string. So here's an example of that. If we click on play on this cell here, we can see that it's going to, first of all, we had two strings, right? It begins and ends with a quotation mark, and another string here, and now it's combined them into a single string. This might seem very simple, but it's something that you'll probably end up doing quite a bit, so it's worth giving that a try. That's why we have an example here where you can try concatenating two strings. So go ahead and give that a try, pause the video, and any two strings, anything that you want. And you can use single quotes or double quotes for your strings, it doesn't matter. So give that a try now, and then come back and I'll show you how to do that, how I'll do that. So for my example, I'll start with a single quotation mark, and I'll say this is A, and then again plus sign is showing that we're wanting to concatenate something, and then for the second one maybe I'll use double quotes just so that we can, it doesn't matter if we combine like a single quote for this string and a double quote for this string. They're both just strings, it's just different ways of telling Python that something is a string. We're going to go ahead and run this one here, and we should see this is a test. So I purposely kind of forgot the space in here. All I'm showing here is that we have space here, but Python doesn't really care about this, right? This can be as many spaces as we want. It doesn't matter. We can click on play, and it's still going to kind of ignore those spaces there, because all that matters is that we have kind of a plus sign here that's showing that we're wanting to concatenate things. And instead of that, we have there's no space as part of this here, right? So if we wanted to actually include a space in the string, we need to put a space in here, right? Because we want that to be in our strings that we're concatenating. So click on play, and there we go. Now we've got a space as you would kind of expect it to look. So moving along. Now we're going to talk about variables and assignment. So everything we've done so far is just kind of giving Python like an equation or a string or something, and it gives it to us right back, which is not the most exciting thing. What we want Python to eventually do is to start remembering things for us. We want it to store things in what's called a variable. So you can think of a variable like a box or a jar or something like that that's on a shelf. And so we need to put a label on the jar because we're going to have like hundreds of these variables potentially in our program. And we need it to find a way to say, okay, what's in this jar? Like, how can I find this particular jar? Or in this case, like variable is what we're looking for. So we need to give it a name. And so here's how we do that. This is what's called an assignment statement. We're assigning something to a variable. And in this case, we are taking a string, in this case Alice, and we're assigning it to the variable student. So we'll talk about what we can use as variable names, but in this case, you can see here, we're just using kind of the word student, and the single equal sign is showing that it's an assignment statement, and we're giving it the string Alice. So we're taking the string Alice, putting it into the jar. That's now, we're putting a label on that and saying it's student. So we run that. Nothing happens. We can see it gives us a check mark. It ran successfully, but nothing actually happens. The reason for that is that we haven't actually got anything back. All we've done here is told this computer that's running in the background to remember this variable. So to actually get it back, we can just type the name student and run that, and we see we get back Alice, which is what we expect. So now we should find out what happens if we use that same variable name, that same label for our jar, and give it a different name here. In this case, we're going to give it the string Bob. So run that cell, and it works successfully. So what happens, let's just check and see what's in student here. Now it's giving us back Bob. So it's saying that the variable student is now showing Bob. So my example here is just to illustrate the fact that if you reuse a variable name, it basically throws out whatever was in there before. It dumps out that jar and puts something new in there. There's no way back to get back Alice now. It's now, the student is now Bob. It's kind of forgotten about what it was before. My last example here is kind of strange. It maybe doesn't make as much sense, but we're going to assign an integer to student instead, to the same variable, and we'll run that, and we see that it worked again. And just make sure that student is saying 5. So that might seem a bit strange because it kind of makes more sense to use a string like we did before. All I'm kind of illustrating this example, I'm going to scroll down here just to kind of show that I mentioned it here in the notes, is that it highlights that Python is what's called a dynamically typed language. So this might not mean much to you if you haven't programmed with other languages before, but in other languages, when you create a variable like we did with student here, sometimes you have to say what type it is. You have to say what data type it's going to be, so you have to say it's a string or an integer. Python isn't like that. You don't have to tell it what type of variable it is, what type of data type it is. You just sort of assign it, and then Python says, okay, this looks like a string, so I'm going to make this data type a string, and then you can change it if you want to. You could change it from a string to an integer. So that can be useful, but it can also trip you up sometimes. If you are expecting to get an integer and you want to do math with it, it might be a bit confusing when you actually are getting a string instead. So it's not super important that you remember the term dynamically typed. I just want to kind of mention that in case you might run into that in the future with Python, and I think it's worth knowing. So how do we check what type of variable is? Well, this is called a function, and this is in particular the type function, and we're going to run that on the student variable. You can see if we hover over it in Colab, it actually tells you what it's storing it as right now. We can see that the type is integer, int, and it's got a value of 5. But if we didn't happen to hover over it, we could use this type function instead. If we click on play, and we'll kind of go into functions more in a little bit here, but it's just sort of saying like, hey, what's the type of this variable student? In this case, it tells us it's an integer. If we were to go back up here and switch it back to Bob again, we expect it to tell us it's a string. So let's double check, and yes, it's telling us it's a string. So just a way of finding out what type something is in case you're not actually sure. So for this example here, we're going to assign several variables. So this is kind of the first example where we've got like a whole bunch of lines of code. So all Python is doing is starting at the top, running everything line by line, one at a time. So running this line, and then this line, then this line, and then this line, until it gets to the end. So the first thing we're doing here is we've got a variable here, a new variable that we're assigning a floating point number, 3.4. And then the second variable, student2 underscore GPA, we're assigning another floating point, number 2, and then the third one as well. So after it has assigned all those variables, it's going to go through, and now we've got some math that we're going to do with those things. So it's going to basically just plug those things in, right? So student1 GPA, it's going to take this 3.4 and plug that into the equation here, and then 2.9, it'll get that from the computer as well, and plug it in here. And then the third one kind of plugs in as well, and it's going to add all those things together and then divide by 3 to give us our average. And then we just print out the average at the end. So we'll run that, make sure it works, and we get our GPA average here. So this isn't a great way of writing code because it works fine if you've got like 2 or 3 variables, but what happens if you've got 100 students in a class or 1,000 students in a class or something like that, right? Like it doesn't scale very well. You don't really want to have 100 or 1,000 different variables with different names. So we're going to look at data structures a little bit later on, and we'll see why that is maybe a better way of handling something like this. But for now, we'll kind of carry on. And so we can see here we were using like numbers and underscores in our variable names, which maybe begs the question, what actually can we use as a variable name? So all you have to worry about is following these 4 rules. So in Python, a variable has to have no spaces in it. It has to use letters, upper or lowercase, numbers and underscores only. It can't start with a number, and it can't be a reserved word, and we'll talk about what that is in just a moment. So here's some examples. I'll just kind of leave that on the screen there too so you can see, of valid and invalid variable names. So this first one is valid. Lethbridge underscore student is fine because we're just using letters and underscores. This one, however, is not okay because it has a space in it. That will not work. Python will throw an error message if you try to do that. Second example, we have uppercase letters, which is fine. It's got a number in it, which is fine because it's not at the very beginning. This one will not work, though, because it's got a number at the very beginning. So it can't start with a number. The next example, customer is fine. It's just, again, using letters. The second example will not work because it's using punctuation mark. A $ isn't allowed. It has to. The only sort of punctuation you can use, or like extra character, is an underscore in your variable name. The last example here might seem a bit confusing because it's like, so why is password okay, but pass isn't? That's because pass is a reserved word. Like, say you're trying to store a user's password, you say, okay, I'm just going to shorten that to pass equals whatever the password is, and you get an error message. Well, what's going on there? It's because it's a reserved word, and in order to find out what those are, you can use this helpful Python function here, help, that will, and then pass it this keywords argument, and it'll tell you, here's a list of all those sort of keywords that you can't use. So not as a variable name, at least. No need to like memorize those. It's just kind of good to know how to find them in case you feel like maybe that's the problem that you're running into. All right, so next we're going to look at comments. So comments are a way of writing stuff in your code that Python ignores. So this can be helpful in case you want to write a note to yourself, kind of explaining what your code does in case you kind of come back to it in weeks or months or something, and you need to remind yourself what it does, or notes to other people that happen to be looking at your code. I can save a lot of time. Then, rather than trying to figure out what something does, you could just explicitly say what it is at the top. So the way that you write a comment is with this number sign or hash sign, whatever you want to call it. And whenever you put that on a line, it ignores the rest of that line. So it's just saying here you can have a comment. Usually you put like a comment saying what something does above your code, but you can also put it on the same line. So here we have a line that's just assigning an integer to a variable called year. And if we want to maybe explain why we're doing this thing here, you can have what's called an inline comment, and then we just put the number sign after the code, and it ignores the rest of the line. So it'll still run this code here, but it'll ignore the rest of the line, because we're saying like, yeah, so maybe we're explaining that this is the year that the university was founded, so kind of just a way of explaining what's going on there. The next example here is another way that you can use comments are just to sort of disable a line of code. Maybe you're getting an error message, you want to turn off that line of code to see if that maybe fixes things. So if we kind of run the code right now, The print statement runs and it just says add a comment before this print function to turn it off. So if we do that, we put a number sign in here and run the code again, it doesn't do anything, right? Because it's now going to ignore that line. So just a quick way of turning off the code without having to delete it entirely, because you might want to kind of come back later and turn that back on again. So it makes it a bit easier to do that. Functions. So functions are blocks of code that you can call that using their name to do helpful things. So we've looked at a few functions already. There's functions that will print text to the screen, get input from a user. They can provide information about a variable. They can do lots of different things. So they kind of follow the format of the function name. So you're calling it with the name of the function, and then an open bracket, and then the arguments. So you can think of functions as like a machine. You have to feed something into the machine, and it does something with it, and then it usually gives you something back as a result. So some functions, they don't need anything from you. You don't have to put anything into it. They don't take any arguments. In that case, it's just like a open bracket and a closed bracket right away. But if you do have to put things in, then you will tell it, you'll put like a variable in like that, or some sort of value in there, and then use commas to separate those things. Each argument is separated by a comma, and you can have a bunch of different ones. This is just to show that you might have more than 2 arguments. So here are some of the built-in functions that come with Python that you can use just right out of the box. And we'll kind of go through them one by one because these are pretty good ones to know. So the print function prints text to the screen. Here's an example of what that would look like. Again, we're calling the print function, use our open bracket, and then we give it a string to print to the screen. We say hello, and then it's going to print hello to the screen. The second example is the type function that we kind of looked at already. So that's going to print the type of a variable, and if we say type and then give it a string variable, it's going to print that to the screen. It'll say str, tell us what type it is. Third example is the input function. So that is going to get input from a user, and it's going to store that as a string. And that's going to be kind of important later, so just try to keep that in mind. So the way that looks is we are calling this input function. In this case, we're not going to give it any arguments. We're just going to leave that blank. And then we're going to store that in a string variable. So we're doing an assignment statement here. Whatever the user types in the box and then hits enter is going to go into this string variable and get stored. We won't get any output from that because it's just remembering something. It's not actually printing anything out to the screen. The next example is len. So this function returns the length of an object. For a string, it's going to give you the length of the string, the number of characters in the string. So in this case, if we do len on the string Lethbridge, it's going to tell us that it's 10 characters long. That's returned as an integer. The next 3 examples here of functions are ones that can tell Python that you want to do something different with a data type. Like you can tell it, like, I want you to treat this data type like a string or like an integer or like a float. You're telling it, like, make sure that you're converting it into this thing. So it's called casting it as a different type. So if we do str on an integer, we're going to then change it. You can't really tell from this example, but now it's going to be treated as a string. If you were to run type on that variable, it would say it's a string. In this case, you can also do switch it to an integer. So you can tell it, change the string to an integer, treat it like a number, and it will switch it to 16, the integer. And you could also tell it, like, to convert something to a floating point number. So then it's going to put the decimal point after it. It can matter a little bit for some like math equations whether something is an integer or because these things are equivalent, right? Like 16 and 16.0, sorry, are the same number, but it can matter a little bit based on different things that you're doing with Python. So sometimes you want to tell it to treat it as one or the other. So we'll look at a few examples here. So the first example is just a couple of simple print statements. And if we run these here, it's just sort of saying that every time you run a print statement, it's going to put it on its own line here. So each print statement appears on its own line because we have 2 separate print statements. The next example here is using that input function that I mentioned before. So we don't have to give input an argument. We could leave it blank. But if we do give it a string, it's just going to print that string onto the screen. And it's a way of kind of telling people what you want them to do. Because otherwise, if you use the input function by itself, it just gives you a box. And it can be kind of confusing to the user because what am I supposed to do with this box? In this case, we're going to be asking the user for their name. So we want to say, please enter your name. And then that function runs, and it gives you the box. Once the user types in something and hits enter, that is what it's like returned, is the name of it. The function is returning a value. So this whole function kind of like poof disappears, and then whatever value they turned into there gets stored into name. Like it doesn't actually disappear, but that's the way of thinking about it, right? Like the string that they enter here is what it's like you're assigning a string to this variable name. So yeah, just a way of thinking about that, I guess. So now we've got a string that the user entered that goes into the variable name, and then we're going to print out hello name. And so we're again doing concatenation here, right? We're going to concatenate the string together, and we can see that like that's all happening inside of this print function here. So we're only giving print a single argument. The comma here is part of the string itself. So we're just sticking two things together. We get a single string, and then we're passing that into the print function, to print onto the screen. So let's run that and see what happens. And we see, please enter your name, because that's our prompt that we gave it here as our argument that we passed into the input string. I'm going to type in my name, hit enter, and it will again concatenate the strings together, say hello Bryson. Okay, so here's again the len function, and this is just showing that we can give it a string that has a whole bunch of characters, and it'll tell us exactly how many characters are in there. It's going to count everything, including the spaces and the exclamation mark, because those are all considered characters in the string. It doesn't include the quotation marks because that's just telling it that it's a string. The string actually is the first character and last character here, like that. And there's 42 characters in there. All right, so here's an example of where we might need to change the type of a variable, like casting it as a different type. So let's say we want to print out a statement about when the U of L was founded. So again, we're going to assign 1967. This is just an integer, right? Years can be considered integers. You don't normally consider them floats. You don't normally talk about like half of a year or something. But in this case, we're going to talk about the year 1967 and assign that to the variable year. Now, if we were to, let's just take this out for a second to see what happens. So take out the function here that's casting this as a year. We can see it's an integer. I mean, if we hover over it, we can see it's an integer because we actually assigned that earlier. We run that in a different example. But if we run it here, it's going to treat this as an integer, and now it's going to say, okay, here's a string, and here's a plus sign, which means we're going to concatenate, right? Because string Python sort of does its best guess, so the plus sign means concatenate, and now we give it an integer, and it's going to get confused. It's not going to know what to do. So this error message might look kind of scary when you run into things like this. This part here especially is a bit confusing. The main thing that you want to look at is it's just kind of telling you what line the error is on. You can see the arrow here is pointing at this fourth line, and the main thing you want to look at is to see this here. It's showing what type of error it is. In this case, the type of error is called type error, and the error message here is can only concatenate a string to a string, not an integer. I can't concatenate a string with an integer. If you ever run into an error message like this and you're not sure what to do, this button here is really helpful. It searches your error message on Stack Overflow, which is a site for programmers. Programmers can ask and answer questions. It's really great. Anyone that does any sort of programming has probably used it a ton, so I definitely recommend using that if you get stuck with an error message. But in this case, I can kind of tell, okay, so it's expecting me to concatenate a string with a string, but actually we've got an integer here, so I'm going to undo my changes, put the str function back in. So now we're going to convert this or cast this to a string. If we run that, it now is very happy to print out the string. It can combine those things together without any problems. Now we'll look at another example. So again, we're using a comment at the top of our program here because it's a few lines long. It might be helpful to explain what it does. And all it's doing is asking the user for their name and then telling them how long their name is. So again, input function, please enter your name, storing that in the variable name. Now we need to figure out the length of the name. So we need to do something to the name variable because that now has our string in it that the user just entered. And so we need to use this len function, right? So we use the len function on the name. It's going to give us back an integer saying how long it is. And we're going to store that back in another variable. You don't have to do that. It's just kind of an extra step. I think it kind of makes it a little bit easier to tell what's going on. If we use the variable name length, we can really tell what exactly it is that we're getting back. And now we're going to print to the screen, your name is string or name length characters long. And again, this is an integer, so we have to change it back to a string, right? So it doesn't give us an error message. So run that, make sure that it works. Please enter your name, type in my name, enter, and we get back your name is 6 characters long. Now's another chance for you to do an example. So this one is going to be a little bit more difficult, right? It's going to take multiple lines of code. So this is where you can write some code to ask a user for their age and then print out their age in 5 years. So this is going to involve that input function, and it's going to involve casting, like changing it to an integer so you can do math on it, and it's also going to involve printing that to the screen. So if you want, you can copy the code above and paste that in there and give that a try, because that's maybe a good starting point. The code is not that different. But give that a try, and if you run into any problems, don't stay stuck for too long. Just kind of jump back to the video here, and I'll show you what I would do to fix that, or to solve that. So we'll get right into it here. Like I mentioned, the code up here is very similar, so I'm just going to copy that because I think it's kind of makes sense to start with that there as the basis. So we could sort of fix our line here our comment, but I'm just going to kind of get rid of it for now because I don't really want to type all that. So we want to ask them for their age. So let's say, please enter your age, just so it's not confusing for the user. And I could leave this variable as name. Python doesn't care, right? It's not like it's doing anything different based on the name of the variable, but I'm going to change it to age just because that makes more sense in the code. It's going to be less confusing for people if they look at it later. We don't need the length of age anymore. In fact, that isn't helpful for us. So we're getting rid of that line. What we need to do is figure out the age in 5 years. We need to do some math, right? So whatever age they type in there, we want to add 5 to it. I could add another line kind of similar to what I did above, but we could also do it inline here. We can do it right in the same line that we're printing things out. So feel free to do it on a separate line if you want to. It doesn't really matter. So I'm going to say, in 5 years, you will be, and then we want to do our age. I'll leave this string function in here because I want to change it back to an age eventually. But we first of all need to do the math on it. So if we just put an age here, we would get back our current age, but we want to add 5 to it, right? So if we add 5, let's start with just that and see what happens, right? So let's say age plus 5 kind of makes sense. Converting that back to a string, not characters long, you will be 5. That's probably the end of the string. We don't need the rest of this here anymore, do we? Get rid of that. So you can see here the print function has all of this inside it, right? We're just giving it, we're doing all this work on it. We're telling it to give us back the age in 5 years. And this is the end of the print statement. If you ever kind of get confused, because sometimes when you're putting functions within functions, like the string function is inside the print function, if you get confused which one's which, if you kind of click on it, it helps you in Colab just to show you that, okay, it's kind of matching up for you. It kind of gives you a box around, okay, this end bracket matches up with this opening bracket, and then this one here matches up with this one. If it helps you to leave spaces like this to kind of further show the gaps, you can do that as well. Python's happy if you can put as many spaces in there as you want to. So let's run this. We'll see if it works. It's not going to, but that's just because we want to kind of highlight an issue. So I'll put in my age, hit enter, and we get a type error. And that's, again, because at the very beginning I've mentioned, whenever you use this input function, it stores whatever the user types in as a string. It's always going to be a string no matter what they type in. Even though this is an integer, Python's going to treat it as a string. So it's treating it like the character is 38, not the number 38. So it can't do any math on it. And that's the same issue that we kind of had seen before. So what we need to do here is use the int function to switch this into an integer. So again, we're kind of nesting more things inside of each other. But we need to switch this into an integer, and we want the int function to be on just the variable age. If we put it around the whole thing, it's going to have the same problem. It's going to be like turn age plus 5 into an integer, but we run into the same problem because age is a string. This might be a little bit confusing. Don't worry if you get a little bit lost here. But what we're trying to do is just turn just age into an integer, do the math on it, and then turn that whole thing into a string. So click on play, enter your age, I'll type it in again, enter, and the program runs and the math works out successfully. It says in 5 years you will be 43, which is terrifying on a personal note, but I don't think I like this program anymore, but that's fine. At least the program works, that's great. We will move on. The next thing we'll look at is just the fact that functions can take 0, 1, or multiple arguments, as I've mentioned. So how do you know what functions are out there? We've kind of looked at a bunch of different examples here of things, but there are more. And one thing you can do is consult the official documentation. I have a link here. If you click on that, it will take you, you'll get a message about leaving Colab. That's fine. We'll kind of carry on. So here's a list of the official built-in functions, and you can kind of read up on them if you want. Sometimes the documentation here is a little bit confusing to understand, but if you wanted to know more about, I don't know, like the zip function, for example, you could say Python zip function, and it will take you to a different site where it might explain things in slightly more user-friendly terms. So feel free to use those resources. But we're going to try another example here of a function that takes a bunch of arguments. So in this case, we're going to use the max function, which gives you the maximum of a bunch of numbers. If we click on play, we get, because there's a combination of floating point numbers and integers as well. Just going to check and see what the biggest one is here. And in this case, it's 9.1. So it's just, yeah, an example of something that has more than 1 or 2 arguments. This one can have as many arguments as you want. Again, just using commas to separate them all. So this is a bit more advanced. If this is confusing, don't stress about it. But you can create your own functions, right? So if it's helpful to, if there's something that you're doing a whole bunch of times in your code, it might be helpful to turn it into a function. The way that you do that is with this def statement. So it's like define, you're defining a new function. Then you give it the name of the function, the thing that you want to use to call it, and then an opening bracket, and then in here is any arguments you want to pass. And if there's more than one, you would just use commas to separate them. You could type in anything here. It doesn't matter. You can type your own. I use miles here because we're doing a function to convert miles to kilometers. And so it makes sense that we're getting in miles, right? You have to pass in miles to the machine that we're going to do something with it. So, but again, call it whatever you want. And then what we're doing here, we'll ignore the return part for now, but we're just doing some math on it, right? So it's some simple math to convert miles to kilometers. So miles times 1.6. It's going to do that math there. And then returning again is just taking whatever you give it, and then it's like the function sort of disappears and replaces it with that value there. So we're going to get back probably a floating point number. Whenever you call the function, it's going to be replaced with that number. So here's an example of that in action. We're going to print convert miles to kilometers. So in this case, we're going to convert 8 miles into kilometers. So we're, name of the function, and then opening bracket, and then the arguments are passing in. So just the same way that you would do that with any other function, right? Click on play, and we get back our result, 12.8. So the reason this is useful, right, is you might have like code, you probably have a function that would do like a bunch of different stuff here, right? Like you could have several lines, so it would save you having to type several lines every time you want to do something. But also, if you have even a simple function like this that does a very simple calculation, if you had code that maybe did this like hundreds of times, and then your boss comes back and says, actually, this isn't accurate enough, we need it to, more decimal places, then you'd have to change that in hundreds of places. So instead of having to do that manually, you could just type in your function here, adjust the function, then every time you call it, it's going to use the new value here. So run it, it's going to use that updated version of convert miles to kilometers, right? So just kind of a good way, it's a good practice to get into whenever you're wanting to do something, even like more than once. Anytime you do something like 2 or 3 times, making it into a function can be a really good idea. So I mentioned data structures earlier. These are a way of provides a way of collecting data into a single variable. Lists and dictionaries are the 2 different data structures that we'll look at today. So the way that you indicate a list is with this square bracket. So these are 3 examples of lists here. The first example is a list that has a bunch of different things in it. So lists can contain the data types that we've looked at already: strings, integers, booleans, and floating point numbers. So here we have a opening square bracket. This is the start of our list. Then we pass in we're giving it a string and an integer and a floating point number. And then it ends the list with a ending square bracket. So it's just basically a collection of items, right? So this is a collection of a string, of integer, and a floating point number. More often you'll see like lists that are just a single type of things, but you can combine different things, which is why I just include that example there. Here's an example of things that are like 3 strings, right? So the first 3 months of the year, or like 3 different booleans. But as you can tell, like it's not structured really, right? It's just a bunch of things in a list. So That can be good, but if you want more structure, you'll probably want to use something like a dictionary, which we'll look at in a minute here. But first, let's look at some examples of strings. So if you're putting things into a string, you probably want to get things out of it at some point. And the way you do that is with their index position. So lists are ordered. So the order that they're in here are the order that they'll stay when Python remembers it. And so you can access this with its index position. The confusing thing about Python and most other programming languages is that you start counting from 0 instead of 1. So this is like the element with index 0, index 1, and index 2. And I kind of show that down here as an example as well. So let's say you want to get something out of it. The way that you do that, first of all, we're just going to use that same list here, right, with the square brackets. We're going to assign that to a variable called student. And what you want to do here, if you want to get something out of student, you use a square bracket and then its index position here. So so student 0 is going to go back and find the thing at the 0 index position, which is kind of the first item, right? We consider that the first item. So we'll give that a try, we'll run it, and we get back Alice, right? Which is the first thing here. If you wanted the element in index position 1, we could run that with 1 and we'll get back 45. Here's an example that is just this month's list is all the months of the year in string form. And let's say we want to get back the month 6. So this is just highlighting the example, or the fact that it's a bit counterintuitive, because you might think the 6th month is June, but actually what we're going to get back here is July, right? Because we're counting from 0. So 0, 1, 2, 3, 4, 5, 6. So getting back July. And we'll just verify that that's true, and that is what we get back. One kind of cool thing is that that len function we looked at earlier that tells you the length of a string, it works on other objects too. And lists are one example of things that you can use it on. So if you use it on this same months function that the months list that we used earlier, and we get the length of that, it's going to give you back 12, right? Because there's 12 different strings in this list. Again, getting slightly more advanced. You don't really need this probably just yet, but it's good to know that you can do this. You can have, not only can you have the other data types that we've looked at so far, you can have lists as well as part of a list. So here's an example of a list with 3 elements. And when you put a list within a list like that, it's called nesting it. They're nested lists. So here's an example of 3 elements, and each element is a list as well. So the first element is a list of 3 numbers, and then 3 other numbers, and then 3 other numbers. So if you wanted to get something out of this, as we know before, like if you wanted the element with index 1, then you're going to get back this one here. And then if you want to get something else within that list, you can use another sort of square bracket again. So now we're going into the sort of second list here and trying to get back the thing from there, like in this case, the thing with index 2 in that list. So let's run this just to make sure we understand how it works. The first thing we're doing is printing out nested lists with index 1, which is this middle one here, right, 0, 1. And it gets this whole list back here, 4, 5, 6. If you wanted to get 6 from there, we would use index 2 to get back, right, 0, 1, 2. And then that's the second example here, is getting back the 6 from there. So don't worry if that is confusing to you. I do want to also mention that if you try to access something that isn't in the list, so let's say you were confused, you're like, oh, and the third element here, let's do 3, forgetting that you're starting to count from 0, so you'd actually need 2 there instead, but you do 3, which doesn't exist. If you run on that, it's going to give you an error message and say, in this case, an index error. It'll say list index out of range, which just means that doesn't exist. All right. Okay, so just to make sure that you kind of get that, we're going to do an example here where you can try to get back an element from a list. So here is a list called presidents that contains these strings that are the former presidents of the U of L, a very U of L-centric example. And so give it a try, just make sure you can get back Cade from that list here, which is right here. So you might have to kind of count it out, but give it a try, make sure you can get that back. And I'll just quickly show you how I do that myself, is again the name of the list, and then we use an open bracket to, like the square bracket to give it the number. And then I might have to go and count here, right? So 0, 1, 2, 3, 4, 5, 6. And if I put that 6 in there, we should get back Cade. run that, and we do, which is great. As an added bonus, just in case you're curious, you can also use, so I mentioned before, integers can be negative, and we can actually use that in our list. So if we were to do -1, it's actually going to start counting backwards. So you go like to the first negative element of the list, like so the end of the list, the first one at the end. So this is going to return man, and we run that. That's what we get. So if we want to cave back here, you could also do -2, and this would be -3, -4, so on. So that is also another way of accessing things using negative numbers to count from the end. Okay, so let's say we want to add something to our list. The way that we do that is using this append method. And I'm going to explain, let's first of all just give it a try and make sure that it works, and then I'll explain kind of what's going on here. So our list before, as you saw, right, was called presidents. We're using the same list up here because Python's still remembering that in its memory in that computer that's running there. And so we're going to say presidents.append. Okay, so append is a method, so we need to use this dot notation here, which we haven't seen yet, but I'll explain in a moment. And we're going to put the string JIAS on there, which is our current president JIAS. So append that to the end, and then print the entire list of presidents. So click on play, and we can see that it worked, right? We see President JIAS has been added to the end. And so what's actually happening here is a method is a special type of function that only applies to a certain object. So lists need a way of adding things to them, right? So what they have is a method, which is a function, right, that is only used on that type of object. So if we were to, I'll just kind of, as an example here, I'll open a new code block. If we were to say just append by itself, right, normally we're used to saying, running our functions with their name, and we'll try to do the same thing here. If we run that, Python's going to complain. It's going to say name error. You haven't used this function before. You haven't told us what this is. This isn't one of the built-in functions that we looked at before, and that's because, right, it's not one of this isn't a function you can just call by itself. It's specific to lists. So you have to use this dot notation to say, like, here's a list. Use this function on it, right? So we're running on that specific list of presidents, and this particular function here is something that will append the string JIAS to our current list of presidents. So if you wanted to find out more, you could, like, you weren't sure what methods were available, for example, you could Google Python list methods, for example, and you could see what methods are available. In this case, we've got what we wanted to, but I just want to point out too that every time you run this function, it's going to add another version, another string of JIAS onto the end here, which is maybe not what you want, which can be maybe a little bit confusing, so just be aware that every time you run this function, it's going to add it to the end. I also want to take this moment to kind of step back a little bit and talk about how Google Colab works. So I mentioned before that if you've clicked this button up here, you're working on your own copy of things, so any text that you change either in the text blocks or the code blocks, that's going to get like saved automatically. Like you can see it, whenever you change something, it'll just automatically save for you. The thing that doesn't get saved, though, are your variables. So I mentioned that the variables are saved on this computer that's running in the background. But what happens if you kind of close your browser tab and then you kind of come back later and you want to pick up from where you left off and kind of, run the examples again? What you might run into here is that, and I can simulate this, if I click this down arrow, I can click disconnect and delete runtime, and that's going to do this sort of the same thing as you would have if you left your code for like more than half an hour without doing something, or if you closed your browser tab and then came back to it. It's just going to say it's deleting the runtime, so we'll say yes, it's kind of getting rid of that computer that was in the background. And so I just want to highlight the fact that any variables that we'd stored in that computer are now gone, right? That computer is no longer accessible to us. If we click on reconnect, we're getting a brand new computer that doesn't have any memory of the other stuff. So we still have all of our code available here to us, right? Nothing's changed here. This hasn't been deleted, but the variables are gone. So if we try to run the same function here, this append method, it's going to say presidents is not defined. And the reason for that is that we haven't actually created our list of presidents yet. We did that up here, right? So if you run this again, now our presidents list has been created. Our new computer here can remember that. And now we can run the method again, and it will append JIAS to the end. So just point that out, that if you kind of come back to things after a little while, and this computer has disconnected for whatever reason, then you might need to kind of make sure that if there's anything that creates a variable, you'll need to kind of go back and then run that cell again. It's not a huge deal, and I try to mostly keep all the cells self-contained, like where they create everything that they need right within that same cell. But just in case you kind of run into that in the future with your own code and examples, then I just wanted to point that out to you. So now let's look at dictionaries. So as I mentioned, dictionaries provide a bit more structure than a list. So a dictionary, very similar to a dictionary in real life, right? That you would open and then you try to find a word. So you'd be looking up a word and finding it and then getting its definition. So that's what we're basically doing with a dictionary. We're saying like, we want to use keys and values. So the key is the word that we're looking up. We're saying like, okay, in this case, we're gonna like have like a student, and we want to give the student a name, an age, and a GPA. So these are the keys here. Name, age, and GPA are the things we're looking up, right? The word we're looking up in our dictionary. And then Alice, 45, and 3.8 are the things we're getting back. We're getting back the name, age, and GPA. So let's go ahead and run this. Click on play, and I should mention, yes, we're using these curly brackets here to indicate a dictionary. And so each sort of thing is a key and then a value, and then we use the colon here to kind of show which one's which. And if you don't have to have a space there, you can have them right next to each other if you want to. I just happen to like having spaces in between things. So each thing, each sort of pair here is the key, and then a colon, and then the value. And use commas to separate them. You can have as many different things in your dictionary as you want to. But in this case, we want to kind of go in and say, okay, get our student dictionary and find the GPA key in there and tell us what we get back. And so we give it a string, right? A string of GPA. You can use other things besides strings. You can use like integers as well, but most often you'll use strings probably as your keys in your dictionary. So we go back and we look up our GPA and get it back, and it's 3.8, which works just as you would expect. What happens if we want to add something new to our dictionary? Maybe we want to add a new sort of element to it, whether the student is suspended or not. So the way that you do that is you kind of treat it the same way you would if you were looking something up. So the same way that we like student, opening bracket, and then the string GPA, we do that for our new thing here, except suspended doesn't exist in our dictionary right now, right? There's no suspended in here. But we look it up and then we just give it a value, and that's going to put a new thing into our dictionary. So in this case, we're going to give it we're going to show that we can put Boolean things in there. We can put any kind of data type in there. You can put also lists inside of dictionaries or other dictionaries. You can kind of nest those as well. But to keep it simple for now, we'll use a Boolean value. So we'll say student suspended equals false. So if you click on print, if we run this here to print out the value of student, the entire dictionary, we can see now that suspended has been added to it and it's been given the value of false. So if you wanted to look it up, you would just run student, name of the dictionary, and then the key of suspended, and it would give you back false. Now, the next example here is to show that you can also assign new values to existing keys. So our current GPA is 3.8. If you needed to update that for any reason, then you can click on play, and it's going to, do the same thing here. So we're assigning it a new value, right? The same way that we assigned, we sort of put a new like key value pair in there. We just look up GPA and give it a new value, and we can see here now that GPA has been updated to 3.7. So it kind of overwrites whatever was in there. So here's a chance for you to try pop quiz. Maybe you didn't expect like a social studies quiz in the middle of your Python tutorial, but here it is. So go ahead and create a dictionary of 3 or 4 Canadian provinces and their capitals. And before you get started, you'll need to think about, so decide either do you want to have a list of provinces and then you get the capitals, like when you look up a province you get its capital, or do you want a list of capitals and once you look up the capital you get the province that it is in. You can do either one. I'm going to, for my example, do the province is the key, so I'm looking up a province and getting its capital. So give that a try, and I'll just show you how I would do that as well. You can pick any 3 or 4 provinces. So for myself, I'm just going to use an open bracket here, or it's a curly bracket, to say this is a dictionary, and I need my first key, so I'll start with Alberta, and the value for that one will be Edmonton. I hope I don't get any of these wrong, because that would be embarrassing. I'll also do British Columbia, and you could like use the abbreviation if you want as well, of course, for the key, just however you want to look it up, right? If you want to look it up with the abbreviation, then use that instead. And that is Victoria. And then our third example, we'll do Saskatchewan, and a colon, and then Regina. Okay, so you can have as many things in there as you want. You could add more things if you wanted to. And then just to test that it's working, we'll do, it's kind of a long name, but provincial capitals. And it's, you can see there's like an autocomplete thing there as well. If it's suggesting something to you, you can just hit tab to automatically fill that in. So we want to get something back. So let's say we want to look up the capital of Saskatchewan. So we'll use our opening bracket, right? And then our string, we're going to pass in the key. And it very helpfully is giving us our examples here. So I'm just going to choose this one here from the list. And this is something that's kind of nice about Colab, is that it gives you those autocomplete things sometimes. So we'll run that, and it gives us back Regina, which is what we expect. I should mention too, so is there, like here we're calling the dictionary directly, getting it back. What's the difference between doing this and using a print function around this whole thing? Because we could also do the exact same thing, right, with this, print, and then wrap the whole thing in a print function. It gives you back the same thing as a result. It doesn't really matter. But Google Colab, basically, if you give it something, like rather than just storing a variable, if you give it something without doing anything with it, it kind of assumes that you want to print it to the screen. So it just kind of prints it to the screen for you. The difference with, like, normal Python doesn't do that. If you give it just a variable name, it kind of ignores it. But Google Colab, it will give you back, if you have a list of several things that give you back like a string, it will only give you back the last one. But if you use a print function for each one, it will print each one individually. So that's one of the differences. It's always a good idea to use a print function around it. Just, because that's a good idea. And if we want to print the entire dictionary, which is I think what I'd said initially to do, you can do that as well and just verify that the entire thing is in there. Okay, so this is where things start to get kind of interesting. We're going to jump into flow control now. And this, like everything we've done so far, Python, you're starting from the top of the code and executing everything line by line, one at a time, until it gets to the bottom and then it's done, right? But most of our programs, we're going to want to do different things based on user input. We might want to do things a bunch of times, because that's kind of the power of computers, right? Is you don't want to have, if you have to type a line for every single thing you want the computer to do, you're not really saving a lot of time. But computers are great for doing things like, very quickly, like through like thousands of times or whatever. So that's what we're going to look into now. But first, before we get to that would be a loop. The first thing we'll look at is an if-else statement. So that's where we're going to start doing different things based on either a variable or user input. Just some value. We'll kind of do different things. We'll execute different lines of code. So scrolling down here, this is an example of what an if-else statement looks like. This isn't actual Python code. This is just sort of pseudocode. This is a way of kind of trying to explain how it looks. But so you can't actually run this cell. This is still just part of the text cell. What we have here is an if statement, and then what we put next is a statement that evaluates the true or false. I put in brackets. You can use brackets. You don't have to. It can just be a statement. So this could be like similar to before, like 16 is greater than 4 or whatever example, something that evaluates to a Boolean statement, and then a colon. And the next thing we do is indent. So when you're writing the code in Colab, it should indent for you after you have this colon here. So what it's going to do is indent for you, and then you can type a line of code here that you want it to do if this statement is true, right? So if this whole statement up here ends up being true, then it'll execute this line of code. And then you hit enter, and then it'll go down to the next line that's also indented. So because these are all indented the same amount, it's all considered one block of code. So it's going to do all three of these things here. If you want to, if you're kind of done executing things in this block, then all you do is hit enter. It'll still be on the same indentation level, so you just hit like backspace or something to kind of go back one level, and then you'll be back on this initial level here. But the way the if-else statement works is it checks if this is true. If it's true, it does these lines of code. If it's not true, then it goes to the else statement. Okay, the else is only run if this statement up here is not true. And again, the else is kind of lined up with the if over here. And then if this thing is false, it executes these lines of code instead, right? This whole block here. And again, once you're done with anything that should execute when this is false, then you hit enter to go to new line, hit backspace, and then it'll be lined up with here, and then it'll kind of carry on from this line of code here. So the way that you can compare things here is kind of the list of different operators that you can use. So there's less than or equal to, and these examples all sort of evaluate to true, by the way. You can have greater than or equal to, right? It's just the both signs right next to each other, greater than, equal to. Equal to is like this, a double equal sign, right? Because we used our single equal sign we already saw was our assignment operator. So if we were to use that, it would assign a value to a variable. But we're not trying to do that here. We're trying to compare two things. So we're trying to say, is 3 equal to 3? In this case, it is. So it would come back with true. There's also not equal to, is the exclamation mark equal to operator there, like that. And then the last one that I'll mention is in. So this is often used in lists. You can use it for other things as well, but basically we're saying, like, is the first thing in the list, or whatever you're trying to check. So is 3 in this thing here? You check, is it here, is it here, is it here? It is, so that's going to come back with true. Yeah, so that might be a little confusing, but I think some examples should help to make more sense of it. So the first thing we'll look at here is a very simple example. So in this if statement here, we've got two separate if statements. We don't have an else yet. We'll look at that in a moment. But the first if statement, we say if false. So this obviously evaluates to false. There's not even like a less than or greater than. This is just going to be always false. So this code here is never going to run, right? It's always going to skip this because this is always false. Here, if true, this is always true. So it'll always run these two lines of code. So we expect it to print these two statements. So if we run that one, we'll just verify, and it does. It prints these two statements here. It does not print this statement up here. So let's look at an if-else statement now. So we run this example here, just to find out what's going to, well, maybe we should first of all look at the comment here. So it's saying it prints a message indicating whether someone is going to pass or fail based on their GPA. So we assign GPA to the variable here called GPA, and now we're going to have an if-else statement. So we'll say if the GPA is greater than or equal to 2.0, then we'll print out a statement. Looks like you're going to pass, and maybe you can have your code do other things, right? If you were, I don't know, actually like writing a code for a registrar or something like that, then you could have it do other things, but it just have to be lined up with this block here. But in this case, so 2.5 is greater than or equal to 2.0. So we print out you're going to pass, and that's exactly what happens. If we were to change this to 1.5, for example, then we run it again, it's going to say, is 1.5 greater than or equal to 2.0? It's not, so then we jump down to the else statement and print out, need to get those grades up a bit. Okay. But what happens if you have more than two outcomes, right? Pass-fail is easy. We can use an if-else statement. But if we have more than two outcomes, we need to start using an else-if statement instead, and that's short for else-if. So this example here, again, we're doing the same sort of thing, but we're going to look at if a person has great distinction or pass or fail. So it's going to check all those things, kind of going down the list. So what we first do here is we assign GPA again, and then we check, is it greater than or equal to 3.75? If it is, we're going to print great distinction. But if it's not, then we jump down to the first elif statement. Okay, so it's going to kind of go down in a line, check each one individually, and then it's going to check until it eventually hits a true. So second example is GPA greater than or equal to 3.5. In this case, it is, so we expect it to say congratulations on honors with distinction. But if this was false, it would kind of keep going and check the next thing, and check if they at least pass, and then if none of these things are true, then else is always going to happen at the end, right? So else is kind of the catch-all at the very end, if none of the other things are true. So it's going to, in this case, if it was less than 2.0, it's going to say need to get those grades up a bit. So we'll just try it, make sure that it works as we expect. And in this case, we see, yes, congratulations on honors with distinction. If we kind of bump this down a little bit to 1.6, then it should kind of go through, and we see that it does go to the else statement because none of these other ones come back with true. So you can also combine these Boolean statements into a single true or false statement. So here we have some truth tables. So we're going to look at and, or, and not. So and or take two different statements, so something on the left and something on the right, so something and something, something or something, and they are going to tell you whether the entire statement is true or false. So if we're talking about and, first of all, it comes back with a true only if both sides are true. So if we look at our truth table here, if the left side is true and the right side is true, the entire statement is going to kind of crunch down into true. But if either side is false, then it's going to come back with the final result as false. And with or, it just wants either side to be true. So either left or right have to be true. If that's the case, then it's going to come back with true. If both sides are false, then it will be also false. Not is a bit different in that it only works with a single value. You put like not something, not true or not false, and it'll kind of flip it. It'll flip it to the opposite. So if you say not true, it'll come back with false. Not false, it'll come back with true. Or like not, and then the name of a variable, it'll flip that variable, assuming that it's a Boolean. Okay, so let's look at some examples of that, or one example of that, I should say. So what we're going to do here, again, looking at the comments, this is a short little line of code that's going to determine if users' GPA, fines, or application status are preventing them from graduating. So here we assign a few variables. We have GPA is a floating point number. Fines outstanding is also a floating point number. And then we have applied to graduate is a Boolean. So the first thing we do is check if we want to check both fines and GPA to see if either of them are causing problems, right? If they have a failing GPA or if they have fines, then that's going to prevent them from graduating. So we use an or statement in this case, right? So it's first of all going to crunch this whole thing here. It's going to say is GPA less than 2.0. Or once we run this, it's going to assign GPA 3.0, so that's not going to be an issue. But the or statement here is saying if the fines outstanding is greater than 0. So if you have fines, then it's also going to stop you from graduating. So always pay your library fines, obviously. But so if either side is true, it's going to jump in here and run this line of code, and then it's done. If these things are both okay, if GPA and fines outstanding are both okay, then it checks to see like has the student applied to graduate. So in this case, applied to graduate is we're saying true, but we're saying if they haven't applied to graduate, that's a problem, right? So if not applied to graduate, then if this ends up being true, it's going to kind of jump in here. So this is kind of confusing, right? Because it's a double negative. So if applied to graduate is false, we flip it to a true, then it's going to jump in here, which gets a little confusing if you are used to this kind of thing, right? But I think it kind of makes sense overall, if you don't think too hard at it, maybe. And then the last thing is if neither of these things are true, then we're going to say you're all set to graduate, everything's fine. So we'll run this here, and we see that we do have fines, right? So we should get kind of tripped up in this first statement here. So GPA is fine at 3.0, and we can now hover over it and see. It's not doing it for me right now, but usually if you hover over a variable, it'll tell you the value of it too. But in this case, GPA is 3.0, which is fine. But the fines are outstanding, so it's going to complain about that. Your GPA or fines are preventing you from graduating. In this case, if we kind of change this back to 0, then it's fine with that, right? And we did apply to graduate, so we're good on there. And now we can jump to the last line and say you're all set to graduate. Okay, so I have another example for you now. We talked before about getting like a username from, or like a password from a user and storing that. So we're going to use an if-else statement now. I'll have you do that as an example, just to try to match whether a password is correct or not. So my big sort of guilty confession to the whole internet, I guess, apparently, right now is that I was a little too obsessed with Nickelback back in the day. So my password for everything was Nickelback forever. So you just keep that between us, just you and me, internet. But we're just going to use that as our password that we're going to try to match for this example here. Not that there's anything wrong with Nickelback, but just saying that if your password is Nickelback forever, you're probably too into them. So there's my confession. Let's go ahead and write some code. So what you want to do first of all, before you get started, is store it. So you want to have like something like stored password or whatever you want to call it. And then this is going to be the string up here. I'll just kind of copy it from, oops, I double clicked, which is editing the string here. So let's quickly copy it from here to make sure that I don't have any spelling mistakes. And now you can write the code. So you want an if statement that's going to check the code, get a user, get a password from a user, like prompt them for it first, probably say like, what's your password? And then they type something in, and then if it matches Nickelback forever, the password of shame, then it will say password accepted. Otherwise, it will say password rejected or try again or something like that. We haven't learned how to do the try again part yet, but we will get to that in a moment. So give that a try. Just to kind of clarify, if you, again, just to kind of highlight, if you're trying to get like back from a line of indentation, like because Python should do the indentation for you automatically after the colon, but if you want to jump back a level of indentation after a line, then you just hit the backspace. So give that a try, make sure it works for you, pause the video if you want to, and I will show you how I'll do it now. So we are going to do that input function that we looked at before, but we want to store the password. So we don't want to use pass as our variable, and very helpfully Python kind of highlights here that it's something different about this than a normal variable. So we're going to call it just password because that's fine. Equals, and then use the input function, and we'll prompt the user saying, please enter your password. You don't have to use like a colon or space or anything here. I like to because it gives you a bit of space and kind of a separation, but you could leave it like this if you wanted to. So we're storing the user input as a string, right, as we saw before in the password variable. And now we want to check it. So we need to do an if statement. So we want to say if password, and the order isn't important here. We can check them either way, but we're going to say equals, right? Remember that checking if two things are equal. We can say if the passwords are equal, and we want to check that with stored password, right? Check these two things. Check our input with the thing that we're storing. If they match, then we want to print access granted or something like that. If they don't match, so now we're going to go down to another line here, and this is where we want to, again, go back, right? We want to hit the backspace so that our else statement lines up with our if, and we're going to put a colon in here, and you can always like kind of scroll up to see the example here if that's helpful. And the else statement, and then we're going to try to, we're going to tell the user that it didn't work, so access denied. Right, that should be all we need. We'll click on play. It just says, please, oh, I forgot to say, please enter your password. Cancel that for a sec, click play again. We can see, yeah, so it's a little bit messy, right, if you don't have like a colon and a space, but it still works just the same way. I'll type in some random characters, hit enter, it says access denied, right? So we'll have to run the program again to check again, but if we type in our password, again, it'll have to match exactly, including the case and everything. Hit enter, then it says access granted. So just as simple as that. Now we'll continue on, we'll look at loops here. So loops are a way of executing a block of code multiple times. We'll look at two different types of loops. The first one is the while loop, and the second one is the for loop. So the while loop here this is our example where we use the while loop. So this is again using a Boolean statement in here, and this statement, as long as it's true, it's going to run the block of code that's indented. So similar to the if statement, right? If this is true, it's going to jump in here. The difference with the if statement is that this keeps doing it. So it'll kind of come back up here again, check again. Is this still true? If it is, then kind of do it again, right? And it'll keep doing it constantly, forever and ever until it runs into a true here. Until it runs into a false here. I said that backwards, I think. While this is true, like while this thing is true, it'll keep going. When it eventually runs into a false, it'll exit, in case I got that wrong the first time. So we'll try running our code here. So we're assigning integer 0 into the variable count. And then we're going to just have it print that the current number is count, then add 1 to it. So we should just see like a basic count of numbers, right? So 0, 1, 2, 3, 4. Again, counting from 0 because apparently that's what programmers like to do. And so it works kind of like we'd expect, right? So kind of count is 0, it's less than 5. That's true. So jump into the block of code here, execute this line, print that the current number is this, and then add 1 to the count. Try it again. Is 1 less than 5? Check again. Keep going, and keep doing that until eventually 5 is 5 less than 5. No, it's not. 5 is equal to 5. So then we jump in, or we exit out of here and kind of carry on from there. I will mention that if you forget, and I'll kind of use the comment to comment out this line of code here, if you forget to increase the count, it's going to run forever, right? It'll always stay 0. It always checks as 0 less than 5, but we forgot to increase the value of count. It'll run forever. If that happens, you just click on the stop button and you can carry on from there. If you're running Python on your computer, Control-C or Command-C, I think, on Mac will cancel your program from running as well. But we'll keep that in there for now. And there's a simple example of a while statement. I'm just going to clear this output here because it's making it hard to get down to the next example. So I mentioned before that while loops are good for getting, or I don't think I mentioned that, but you can use this to get input from a user constantly, right? Until the user enters the right password or something, you could keep prompting them until they eventually type the right password. So similar to our example above, we've got stored password here, and we're getting a password from the user. And we're going to check, does the password match? And now that we're using a while statement, it's going to keep checking. So does the password match? If it doesn't, again, this is the not equal to sign. If password doesn't match the stored password, now we're going to go in here and then say the password is incorrect and ask for the password again. Do the same thing, input, please enter your password. And it's going to keep checking until the password's matched, right? Once these are equal, then this will become false and it will exit out of this while loop. So let's give it a try, click on play, and we can again type some characters, hit enter. It doesn't match the password that we've stored, so it's going to say password incorrect, please enter your password. And we're going to enter our password. Again, case sensitive, so you have to type it in exactly. And it says access granted. Now we'll look at for loops very briefly. For loops are great when you want to do something with every element of a list. Each single element of a list, you can use it on other things besides lists, but lists are a great sort of simple way of looking at what for loops can do. So the syntax here, the way that you write the code, is for temporary variable in list, or whatever thing you're going through trying to do something on each element of it. You could do it for a string, I think, if I'm not mistaken. I think it would just do something for each character of the string. But in this case, we've got a list, so it's going to, Python's smart enough to say, like, okay, so if you say for student in students, right, because we've got a list of students here, Alice, Bob, and Coraline, 3 strings. For each student, each string in here, print welcome, and then the name of the student. So what's happening here is, again, this in statement we've looked at before, it's got a slightly different sort of usage within a for statement. It's not quite the same, right? Like we're doing something kind of different here. We're saying, so for each student in students, we look at students here, we grab the first one, and we assign that to our temporary variable here. So we could call this whatever we want. It doesn't have to be student, and just to kind of highlight that, I'll change it to S here. For S in students, print welcome, and now we need to change this here to S as well, right? So these things have to match because it's basically saying, like, make a temporary variable, put the value into it, and then do something with it. So in this case, we're jumping into our block of code here, and we're going to execute it, and then we go back, get the second thing here, put Bob into S, welcome S, and then do the same thing for Coraline. It will, once it runs out of things to work on, then it exits and kind of carries on and goes back to the next sort of line of code over here, and we'll carry on from there. So we'll run that, make sure it works, and we see welcome Alice, welcome Bob, and welcome Coraline, as we expect. Okay, one more sort of example before we're done is try writing a for loop that goes through a list of names and tells you whether a name is longer than 6 characters. So you first of all need to create a list of names, make sure that some of them are longer than 6 characters, and then I would recommend a for loop. Use a for loop for that one. Go through each element and then use an if statement and find out if it is longer than 6. If it is, just print a statement out to the screen saying that it's longer than 6 or something like that. Otherwise, if it's not, then print a statement saying that it is not, and go from there. Because you can, I haven't really showed that, but you can hopefully imagine how you would nest an if statement inside of a loop, right? So it all depends on the indentation. If you've got a for loop, you can then have an if statement, and then you kind of indent it from there. So you're going to have multiple lines of indentation on this one. I hope that it makes sense. If you, again, get stuck, don't stay stuck for very long. Jump back, and I'll show you how to do that. So feel free to pause the video, and I will now show you how to do this. So to start out with, we need a list of students. So I'm going to make a new list called students, and again, square brackets to make our list. We'll start with Alice. We'll do Bob as well, and we need a long name, so we'll do Christopher. We need to do our for loop because we need to go through the list of students. So we'll say for, again, I'm going to call it student in students because I think it makes sense that we're taking each individual student and doing something with it. In students. And again, our colon is telling us that we're jumping into our for loop now. That's just kind of the syntax of the for loop, right? Now we need to do an if statement. We need to check and see if each string is longer than 6 characters, right, using our len function. So if student, right, this is going to be the string. We need to do the length of the student, the string student, is greater than 6. Is that what I said? Longer than 6 characters, yeah. Otherwise, if it was 6 or longer, it'd be greater than or equal to, right? If it's longer than 6, jump in here, and we want to print something out. So we can say, I don't know, let's say maybe the name of the student. So we'll use that variable here to get the string itself. Student is a long name, right? Because it's something that's longer than 6 characters. And then if we can just use an else statement to say it is not longer than that. So in this case, we'll say print student is a short name. Okay, that should be all that we need. And then, yeah, hopefully it was clear to see, like, we're, in this case, jumping into our for loop here with for each student, we're going to run this, like this is one block of code, right? This whole thing is a block of code now within the for loop. And within that, we're doing the if statement. So if this is true, then we jump into this block of code, which is just one line long, but it's still like a block of code. If it's not true, then we do this block of code. Okay, and then we do this whole thing again, do this whole if statement, if else statement again, and then a third time for if you had like 100 names in your list, then it would do it 100 times, right? So let's give it a try. Hopefully I got that right, and it looks like it worked. So we say Alice is a short name, Bob is a short name, Christopher is a long name. Okay, so that's everything I have for this this lesson, this section. I am working on part 2 of this, and I don't have it ready yet, but I'm hoping to have it ready for spring 2023. So if you're watching this in spring 2023 and it's still not available, you can send me an email and shame me for that. But keep an eye on the library website, and we'll have some in-person workshops where you can go through this with me in person if you'd like. But otherwise, thanks for following along. I wish you the best of luck with your Python journey. If you want to look at the Project Sandbox website on from the library homepage, you can see some resources to kind of carry on from here. But otherwise, feel free to wait, and if you want to carry on with part 2, I'll hopefully have that available soon. So thanks again. Have a great one, and thanks for joining me.